Hello friends, this is Jiten Jain, and in this video I am going to explain you how to plot root locus, what are different steps to plot root locus. So for that you have to remember first step, that is symmetricity. So first step is symmetricity. Always remember the root locus diagram is always symmetrical about the real axis, and the reason is the poles and zeros always comes with complex conjugate pair. So if the one pole is -1 plus j, second pole will definitely be -1 minus j. So the poles and zeros will always be symmetrical about the real axis. That's why the root locus diagram will always be symmetrical about the real axis. So this is the example of uh, a part of root locus. So you can see that zeros and poles are symmetrical about the real axis. That's why the root locus is also symmetrical about the real axis. So, and the second reason is that the symmetricity is also depend on the graph sheet on which you are plotting any diagram. Suppose you are plotting root locus diagram or Nyquist plot, both will be in the same type of graph sheet, linear graph sheet. That's why the plot is symmetrical. But if you talk about Bode plot will be plotted on the semi-log paper, which is not linear. That's why the Bode plot is not symmetrical. Okay. So first step is symmetricity. You have to remember that always root locus is symmetrical about real axis. Second step is number of root locus branches. So you have to calculate number of root locus branches. So if the number of poles is greater than number of zeros, then the number of root locus branches will be equal to number of poles. And if the number of poles is less than number of zeros, then the number of root locus branches will be equal to number of zeros. Okay, this was the simple step. Then the third step is existence of root locus branches on real axis. Okay, so for the root locus branch to lie on the real axis, the sum of the number of poles and zeros to the right hand side of that point should be odd. Okay, suppose you have to find that whether the right of this point, right hand side of this point, uh, the root locus will exist or not on real axis. I am talking only about the real axis. So what you have to do, you have to suppose for you have to find the right hand side of the origin. So you have to put your finger on the origin, and now you have to calculate the sum of number of poles and zeros to the right hand of that point, which is 0. Here no poles and zeros are there, that's why sum is 0. 0 is even, so no root locus will be there. The sum should be odd. Suppose you have to find the existence of root locus on the real axis on the right hand of this point. So for that you have to calculate sum of the number of poles and zeros, which is 1. Only one pole is there, so that's why, which is odd, that's why this portion will be there will be there should be exist there should exist a root locus branch. Similarly, here if you put finger here, so if you see right hand of that point, there are two poles which is even, so no root locus will be there. And if you see from here, so there will be a root locus branch. Okay, so yeah, so the poles always moves on the root locus branch. What is root locus branch? Root locus branch is the locus of, or root locus is the locus of the pole. Okay, and the k is the parameter. Again, if you vary k from 0 to infinity, the root locus branch will start from pole and it will end to the 0. Okay, for example, uh, to clarify the third rule, existence of root locus on real axis, you can solve this problem. Identify the real root locus branches to the given system on the real axis. So, yeah, open loop gain is given GSHS. Okay. So now you plot the poles and zeros on the real on the S plane. So S is equal to 0, S equal to -3, -10. There are 3 poles and 2 zeros. Okay, now you have to find whether there is a root locus branch on real axis or not. So you have to put finger first on the origin or first pole. So if you put finger here and on origin, and now you see toward right side, there is no pole or zero. So zero pole or zero. So zero is even. So will be no root locus branch. You can there is no root locus branch. Now if you see from s equal to -1 toward right side of S plane, so there is one pole which is odd, so there will be one root locus branch. Similarly you can calculate other point also. So fourth step is asymptotes. Okay, you have to find number of asymptotes. What are asymptotes? Asymptotes are straight lines which are approaches to the infinity. Okay, so it is a straight line which approaches to infinity. It gives direction to the zeros at infinity. Okay, and you can calculate from n equal to p minus z. Number of asymptotes is equal to p minus z. Okay, difference between poles and zeros is number of asymptotes, and angle of asymptotes is important point. Theta equal to 2q plus 1 into 180 divided by p minus z, where q equal to 0, 1, 2 up to p minus z minus 1. This is simple formula you have to remember. So the asymptotes are symmetrical about the real axis. Okay, and the asymptotes give the direction of zeros when the p is greater than z. Number of poles are greater than zeros, then the asymptotes give the direction of zeros. Okay, few points you have to remember, not very important, but you have to remember. So fifth step, this is important. All steps are important, but all steps are important, you have to remember that. Fifth step is centroid. It is the intersection point of asymptotes on the real axis. Okay, because plotting asymptotes is important. Now, if you want to plot asymptotes, you have to find centroid also. So sigma or centroid is equal to summation of real part of the poles minus summation of real part of zeros divided by p minus z, where p is the number of poles, z equal to number of zeros. Centroid may be located anywhere on the real axis. It may or may not be on root locus branch. Okay, centroid is mainly required to draw the angle of asymptotes. Okay, so to clarify the concept of asymptotes and centroid, we can solve a problem. Find the angle of asymptotes and centroid to the given system. System is given gh equal to k upon s into s plus 2 s plus 4. Three poles are there at 0, -2, -1. Okay, and number of zeros is 0. So number of root locus branches will be n equal to p minus z. N is equal to p because p is greater than z. So 3 branches will be there. Okay, step by step you have to go. Then you have to plot the root locus on the real axis. Okay, and you can plot here. Okay, so there is root locus branch between s equal to 0 to s equal to -2 and s equal to -4 to infinity. Okay, 2 branches already we had found, but the third branch is unknown. So number of asymptotes. Okay, so fourth step is number of asymptotes equal to n equal to p minus z equal to 3. So 3 asymptotes will be there, and angle of asymptotes will be equal to this formula we will use, theta equal to 2q plus 180 divided by p minus z. So put q equal to 0, 1 and okay, 2, 0, 1, 3 minus 0 minus 1, 0, 1, 2. Okay, so you will find 60 degree, 180 degree, 300 degree. So 3 asymptotes are there, and centroid will be equal to -2. So at -2, s equal to -2, all 3 asymptotes will be intersect on the real axis. Okay, now you can plot asymptotes. This is one asymptotes, this is second, this is another. Okay, so what is breakaway point? So sixth step is to calculate breakpoint. Breakpoint are two types: breakaway, break-in. So what is breakpoint? The point at which two or more poles meet or two or more zeros deviate from that point is called breakpoint. Okay. So how to calculate breakpoint? So breakaway point, break-in point. I have told you break point is or are of two types. Breakaway point. The point at which the root locus branches or poles move away from that point is called breakaway point. And break-in at which two root locus branches enter into the point or poles enter into the point is called break-in point. Okay, the root locus branches enter or leaves the real axis with an angle of plus minus 180 degree divided by n, where n is the number of poles at that break point. So this is a trick. Okay, if you don't remember, that will also be fine. Procedure to find the location of break point. So there is simple steps to find the break point. First of all, form the characteristic equation 1 plus GSHS equal to 0. Then rearrange that equation in terms of k equal to f of s. Now differentiate k with respect to s and make it to 0, dk by ds equal to 0. And this equation will give you valid and invalid breakpoint. So to find the which one is the valid breakpoint, put it into the step number 2 and find whether the key is positive or negative. For valid breakaway point or break-in point, the key should be positive or it should lie on the root locus branch. So intersection point. So intersection with point with imaginary axis is the seventh step. You have to find intersection point with imaginary axis. To calculate it, form the characteristic equation 1 plus GSHS equal to 0. Write the Routh tabular form. Find the k marginal value. You know what is k marginal value? At which the poles are at imaginary axis. Form the auxiliary equation. The roots of auxiliary equation will give you valid and invalid intersection point with imaginary axis. For valid point, k marginal should be positive. Okay. Now for clear that concept, we can solve this problem. Find the intersection point with imaginary axis to this system gh equal to k upon s into s plus 5s plus 10. You have to write characteristic equation. Now write tabular form. Now find k marginal value. Now write auxiliary equation, put k's value and find the s value. Okay, now you found s value. So this is the intersection point to the imaginary axis. Okay, so last step is calculate angle of departure and arrival. So the angle of departure is calculated at complex conjugate poles and angle of arrival is calculated at complex conjugate zeros. So how to find angle of departure? So the formula is this: phi d equal to 180 plus summation plus angle at a positive imaginary complex pole. Or simpler formula is this: phi d equal to 180 minus phi, where phi is equal to summation phi p minus summation phi z. This is angle of departure. For angle of arrival, the formula there will be slight change in formula. 180 plus phi will be there, only plus. Okay. I hope you got the all points or steps to plot the root locus branch, but to further clear it, you have to solve a complete problem. Okay, we'll do in next video. Thank you.